Hello everyone, welcome back to the channel. In today's video lecture series, we are diving into a fundamental topic from ground improvement techniques, that is compaction of soils. This is one of the most important concepts in geotechnical engineering because it directly influences the strength, stability, and performance of the soil which is used in construction. Let's quickly explore what compaction is, why we do it, how we evaluate it using laboratory tests like Proctor and modified Proctor test, and where compaction is used in real field applications. So as we move on to the definition, compaction is defined as the process of densifying a soil mass by applying mechanical energy. In simple terms, we pack the soil particles closer together by removing air voids. This is not same as consolidation where water is expelled over time, whereas in compaction the change happens immediately due to mechanical effect. So the purpose of compaction is to increase the soil strength and to improve the stiffness and reduce the settlement and thereby increasing the bearing capacity of the soil. And it also reduces the permeability of the soil. So whenever we see structures like roads, embankments, pavements or foundation performing well for years, it is mostly because of the soil underneath has been properly compacted. So the various laboratory tests used to estimate the amount of compaction of soil are as follows. Let's look at the two important laboratory tests used to study the compaction characteristics of soil. The first thing is a standard Proctor test. Here we compact the soil in three layers using hammer weight of 2.5 kilograms and height of fall of 30 centimeters with 25 number of blows per layer with the diameter of mold as 10 centimeter and height of the mold as 12.5 centimeters. The goal is to determine how the dry density of soil varies with the water content. Next is the modified Proctor test where 4.5 kilogram hammer is used. It is used for heavy duty structures like airports or high load pavements. The modified Proctor test is used. In this method, 4.5 kilogram hammer is used and height of fall is 45 centimeter. The number of layers is 5 layers and 25 blows per layer is given. You can clearly see that the modified test uses a higher compactive effort. This produces higher density of soil. So this picture represents the OMC and MDD curve. Once the test is conducted for various water contents, we plot a curve known as compaction curve, which shows how dry density varies with moisture content. The curve peaks at a point where soil achieves its maximum dry density. This point is called OMC optimum moisture content and MDD maximum dry density. So why optimum moisture content exists? At lower moisture content, there is no enough lubrication between the soil particles, whereas lesser density is achieved at lower moisture content. If we increase the moisture content, the density of the soil also increases up to a certain limit, that is the peak value of optimum moisture content, and after that it gradually decreases. So this helps the air voids getting replaced by water and producing a compactive effort. This understanding is critical for determining the moisture level required in the field before using rollers. So the various applications of compaction are: it plays a major role in all forms of earthwork construction. Some common applications are highway construction, embankments, airfield pavements, etc. So let us go to a quick assessment. So what are all the dimensions of a compaction mold? So what is the number of blows per layer is used in modified Proctor test, and what is optimum moisture content? So take time for answering these questions. So the references used are listed below. So in this video, we have learned about the definition and purpose of compaction and the tests conducted such as standard and modified Proctor test and OMC and MDD concepts related to soil compaction and real world applications of compaction. So if you found this video helpful, don't forget to like, share and subscribe for more civil engineering concepts. See you again in next video. Thank you.